Hello everyone, welcome back to my channel. I'm here with another topic which is under the similar subject called Storage Area Network, which is local replication technologies. Before we move into the introduction, let's know what is local replication. Local replication refers to replicating data within the same array or the same data center. Local replication technologies are used to create copies of data within the same storage system or on a separate storage system in the same location. These technologies are essential for data protection, disaster recovery, and data availability. So let's know what is replication. Replica, an exact copy. Replication means the process of reproducing data. Local replication means replicating data within the same array or the same data center. Local replication can be synchronous or asynchronous depending on the level of consistency required between the primary and replicated data. So replication technology is a process of making multiple copies of data and storing them at different locations for backup purposes, fault tolerance, and to improve their overall accessibility across a network. So similar to data mirroring, data replication can be applied to both individual computers and servers. As we can see from source, the data is replicated and stored in a replica, which is the target. So next, let's look into the benefits of local replication technologies. Local replication technologies helps organizations ensure data availability and minimize downtime in case of any system failures. So they provide a cost-effective way to create backups and replicas of critical data without the need for off-site storage. As we can see, the host-based replication, that is the LVM-based replication. So LVM is nothing but logical volume model. So we can see the host and logical volume in another diagram, and it has replication data of physical volume 1 and physical volume 2. And local replication can also improve performance by allowing for faster access to data copies. So let's look into the types of local replication technologies. So the local replication technology has snapshots, clones, mirroring. So snapshots means point-in-time copies of data that can be used for backups, testing, and data recovery. Clones means full copies of data that can be used for development, testing, and analytics without affecting the primary data. Mirroring means real-time replication of data between storage systems to ensure data availability and redundancy. And we have another type, that is peer-to-peer replication. So in this type of replication, each server can act as both a master and a slave. Then the data is replicated between all the servers in peer-to-peer way. And as we can see, host-based and storage array-based. So in host-based, logical volume manager, that is LVM, based replication, that is LVM mirroring, and then we have the file system snapshot. So under storage array based, we have full volume mirroring, pointer based full volume replication, and pointer based virtual replication. So these are the types of local replication technologies. Next, let's look into what is snapshot technology. Snapshot technology captures the state of data at a specific point in time without requiring additional storage space. So let's know what is block level snapshot. Block level snapshot increases RPO, that is recovery point objective, and recovery time objective, that is RTO. Snapshots can be used for data protection, recovery, and testing without impacting the performance of the primary storage. Administrators can schedule snapshots to occur at a regular intervals to create multiple recovery points. And as we can see, there are two levels, that is in block level and in file level. So the snapshot increases in both the levels, that is block level and file level, and also RTO increases as well, that is recovery time objective. Next, let's look into clone technology. Clone technology creates full copies of data that can be used for various purposes such as development, testing, and analytics. So it does not affect the primary data and provide a way to work with data without risking its integrity. Administrators can create clones on demand or schedule them to occur automatically at specific intervals. So let's know what is mirroring technology. Mirroring technology replicates data in real time between storage systems to ensure data availability and redundancy. So mirroring can be asynchronous, where data is written to both systems simultaneously, or asynchronous, where there is a delay between the written systems. Mirroring is commonly used for disaster recovery and high availability scenarios. As we can see the diagram, there is a client and two systems, that is active and standby, and we can see the data replication is happening between them. Let's consider what's implementing local replication technology. So organizations should consider factors such as data consistency, recovery point objectives, that is RPOs, and recovery time objectives, that is RTPOs, when implementing local replication. So it is essential to test and validate the replication process regularly to ensure data integrity and availability in case of failures as well. So storage capacity, network bandwidth, and performance impact are also important considerations for choosing the right replication technology. Next, let's consider the best practices for local replication technologies. So establishing a clear replication strategy based on organizations' data protection and availability requirements. Then monitor replication processes regularly to ensure they are functioning correctly and meeting defined objectives. Implementing encryption and authentication mechanisms to secure replicated data and prevent any unauthorized access. Let's see the case study of company A's implementation in local replication technology. So the company A implementing snapshot technology to create regular backups of their critical data. So the use of snapshots enabled quick recovery of data in case of any accidental deletions of or system failures or any other issues. So company A saw improved data protection and availability, leading to increased operational efficiency. As we can see the diagram, we have primary and secondary, and between them is a system replication that happens that happens uh, that happens in log and catalog backup and file-based backup. So log and data backup volume need to be accessible by both hosts in order to enable forward recovery and retention management, independent which host is primary. Now let's see the case study for company B's implementation. So company B implemented mirroring technology between two data centers to ensure data redundancy and availability. The real-time replication of data helped company B achieve their disaster recovery objectives and minimize the downtime. Company B's investment in mirroring technology paid off during a major system outage as they were able to fail over seamlessly to be the replicated data. So as we can see, the connectivity between two data center to ensures the data redundancy and availability. Next, let's look into the challenges of local replication technologies. So one of the challenges of local replication technologies is that the impact on their performance, especially during high activity periods. And managing multiple copies of data can also lead to increased storage requirements and complexity in data management. And ensuring data consistency and integrity across replicated copies can be a challenge as well, especially in asynchronous replication scenarios. Now let's look into the future trends in local replication technologies. So the future of local replication technologies is likely to focus on automation, efficiency, and integration with cloud services. As we can see the future trends in the diagram, AI engineering, distributed cloud and edge computing, privacy computation, Internet of Behaviors, and so on. Machine learning and artificial intelligence may play a role in optimizing replication processes and predicting data protection needs. Organizations may also explore hybrid replication models that combine local and cloud-based replication for enhanced data protection and availability. So these are the future trends in local replication technologies. Now let's see the comparison of local replication technologies. So what's the difference between snapshots, backups, and replication? So snapshots are ideal for creating point-in-time copies of data for backup and recovery purposes. Clones are useful for creating full copies of data for development testing and analytics without impacting the primary data. And mirroring provides real-time replication of data for disaster recovery and high availability scenarios. Now we have reached the conclusion of local replication technologies. So it plays a crucial role in ensuring data availability, protection, and redundancy. So organizations can leverage snapshots, clone, and mirroring technologies to meet the data replication needs. By understanding the benefits, types, challenges, and best practices of local replication technologies, organizations can create a robust data protection strategy. So this is the end for local replication technologies. Thank you, one and all.